Welcome to this video on cement manufacturing, process and quality control. We'll explore the complete technical guide from quarry to quality bag, following Indian standards. I'm Abhijit Atre, with over 26 years of industry experience.
Our journey is divided into two parts. Part A covers the manufacturing process, from raw materials, quarrying, milling, preheating, and the rotary kiln, to grinding and dispatch. Part B focuses on quality control, including QC philosophy, raw mix, kiln, clinker, and cement testing, along with statistical process control and a quick reference to IS codes.
Cement manufacture relies on a carefully proportioned blend of calcareous, argillaceous, and corrective raw materials. Limestone is the primary component, providing 75 to 80% of the raw mix. Clay and shale provide the argillaceous materials. Iron ore, bauxite, sand, silica, and gypsum are used as corrective materials to achieve the desired clinker chemistry and quality.
Stage 1 is quarrying, crushing, and pre-homogenization. This involves limestone extraction, crushing with primary and secondary crushers, and creating a longitudinal pre-homogenization pile. Key QC checks focus on blast design, face sampling, target calcium carbonate, crusher settings, moisture control, pile height, reclaim consistency, and contaminant checks.
Stage 2 is raw meal preparation in the raw mill. Common types include ball mills and vertical roller mills, or VRMs, which are highly energy efficient. Blending silos ensure the raw mix chemistry is consistent. Raw mix quality is governed by key parameters like LSF, SM, AR, calcium carbonate, fineness, and moisture content, each with specific target ranges and significance for clinker properties.
Stage 3 introduces the preheater tower and pre-calciner, an efficient heat exchange system. The preheater tower has several cyclone stages for gradual heating, drying, and clay dehydration. The pre-calciner achieves 85 to 95% decarbonation. Key QC monitoring points include temperatures, kiln inlet draft, and alkali bypass to maintain efficient operation and product quality.
Stage 4, the rotary kiln, is the heart of cement manufacture. It is where clinker minerals are formed at peak temperatures of around 1450 degrees Celsius in the burning zone. The chemical reactions progress from calcination through solid-state reactions to liquid phase formation, culminating in the maximum formation of tricalcium silicate, or C3S.
Stage 5 involves clinker cooling and storage. Rapid quenching in a grate cooler is critical to preserving the clinker's reactive mineralogy. Satellite or planetary coolers are found in older plants. Clinker is then stored in silos or open piles, often for over 7 days, to allow temperature equalization. QC tests focus on free CAO, LSF, burnability, compound composition, bulk density, and clinker temperature.
Stage 6 is cement grinding and the finish mill. Clinker is ground with gypsum and supplementary cementitious materials, or SCMs, like fly ash, slag, or silica fume. This can be done in ball mills or more efficient vertical roller mills, VRMs. Grinding is controlled via mill temperature, water injection, and grinding aids to achieve the desired fineness and cement properties.
Stage 7 covers cement silo, packing, and dispatch. Cement is stored by type and grade in silos before being bagged by rotary packers with high weighing accuracy. Outward quality release requires sampling, physical and chemical testing per IS codes, and certification. BIS marking license is mandatory for dispatch.
This flowchart summarizes the entire cement manufacturing process, starting from quarrying and ending with dispatch. It highlights the main stages, from raw material preparation and milling, through pyroprocessing and cooling, to final grinding and packaging. Note that supplementary cementitious materials and gypsum are added at the cement mill stage.
The quality control philosophy follows a closed-loop system: plan, sample, test, analyze, and correct. Key QC pillars include IS 4905 sampling, laboratory analysis using XRF and XRD, monitoring via SPC charts, BOG compound calculations, LIMS software, QA procedures, and rigorous lot release protocols.
Raw mix QC relies on 3 moduli: lime saturation factor, LSF, silica ratio, SR, and alumina ratio, AR. These moduli determine clinker compound composition and quality. For each factor, specific target ranges, the consequences of low or high values, and practical corrective actions, such as adjusting raw material proportions, are clearly defined.
IS 4031 outlines mandatory physical tests for cement quality control. These include tests for fineness, soundness using Le Chatelier and autoclave, consistency, setting time, compressive strength, and specific gravity. The significance of each test relates to important cement properties like reactivity, strength, durability, and mix design.
Cement chemical analysis according to IS 4032 is essential, typically performed using XRF. Key oxides like calcium, silicon, aluminium, and iron are monitored within specific limits. Parameters such as magnesia, sulfur trioxide, loss on ignition, insoluble residue, free CaO, and alkalis are also tightly controlled due to their potential high-value effects on cement quality and durability.
Statistical process control, or SPC, is critical for consistent cement quality. We use X-bar and R charts to monitor process average and variability. CPK assesses process capability, aiming for a value of 1.33 or higher. CUSUM charts are useful for detecting small, sustained shifts in raw meal chemistry.
A modern QC lab includes online, offline, and advanced analytical equipment. Online analyzers, like the Crossbelt Analyzer and online XRF, provide real-time data. Offline labs handle standard tests using equipment like XRF spectrometers and Vicot apparatus. Advanced analytical tools, such as XRD and SEM, support research, development, and certification.
Indian standards, or IS codes, govern cement production and quality. Key codes define product specifications for various cement types, like IS 269 for OPC and IS 12269 for 53-grade OPC. Other codes specify methods for chemical and physical testing, sampling, and guidelines for concrete mix proportioning and ready-mixed concrete.
This chart summarizes the critical QC parameters across all manufacturing stages. We monitor calcium carbonate in the quarry and raw mill, fineness at crushing, and temperature and gas composition in the kiln and preheater. Clinker quality is checked via free CaO and burnability, while cement is controlled by blane fineness and setting times.
Key takeaways include raw materials, governed by LSF, SR, and AR, control quality. Kiln operation at 1450 degrees Celsius maximizes C3S formation. Clinker QC requires free CaO under 1.5% and proper quenching. Cement quality demands blane fineness above 370, mill temperature below 115 degrees Celsius, and SPC compliance. Finally, BIS CML is mandatory for cement market supply.